Today is distance learning day 13. This is Raja. So I wanted to go over a couple of the due dates for you. First off is today is quiz day. Make sure you get on Test Wizard and take the quiz. Okay, as usual, you should only be using your non-graphing calculators and your reference tables, nothing else. I don't want to hear about you have your cell phones or anything else, okay? It will be timed, just get it done. The second thing is your quest is due on Monday. That's also on Test Wizard. Some of you guys are having issues where the grade on your end says a really nice grade and the grade on my end or Mr. Gonzalez's end says a 0. Do yourself a favor, just until we put the grades in, just snapshot a picture of it, and that way you have it in case there's some sort of an issue. All right, on Wednesday before break, okay, it's going to be the Rock and Mineral 1 exam. And the reason we call it the Rock and Mineral 1 exam is because rocks are taking a lot longer than we expected. We thought we'd be able to get all of rocks into 1 week or within 6 days. It's not going to happen. All right, the videos are hopefully helping you guys and you're taking them seriously. All right, the new thing is we will be giving you guys a review quest over break. Okay, we want to give it to you guys early, so we'll give it to you next week. All right, and it will be due the day we get back to school. Okay, the reason we say it's the day we get back to school is because after break, we're supposed to go back on the 20th. We don't know if that's true or not, but we're gonna pretend like it is until we hear otherwise. This review quest is also going to be a Regents. It will be on Test Wizard, but that way you guys can see everything that we've been telling you all year is true. Like the Regents questions we've been giving you all year will show up on these Regences, okay? So what we really are looking for is the fact that you guys are going to be using those test taking skills, right? Underlining, highlighting, writing definitions off to the side, whatever it is, okay? And that you're doing well on them. All right, well, we miss you guys and hopefully we'll see you soon.
Alright guys, so in today's video we're going to talk about something called igneous intrusions. Now igneous intrusions are large masses of igneous rock that occur below the Earth's surface. They're intrusive. Remember, we use this term to describe rocks that crystallize below the Earth's surface. Now, the other thing with intrusive, this word should sound familiar to you. It should sound like intruder. And that's because that's exactly what happens in these guys. In these guys, what basically happens is that you have rock that's sitting there and you get a massive influx of magma. Magma comes in for some reason, okay? Any number of reasons, plate tectonics, lots of things that we'll talk about later. But what basically happens is this magma works its way into an area and it melts the rock that's around that. And so it melts the rock that's around that. That rock becomes part of the magma, and then it sits there. It doesn't break through the surface, so it doesn't turn into a volcano or anything like that. It just kind of sits there and slowly starts to cool off. Once this magma cools off completely, it's going to form a large mass of intrusive rock, like a granite or a diorite, and we call these large masses of intrusive rock plutons. Now, there are lots of different shapes and ways that this can take, and remember, this is going to take a very long period of time. But if you look at the chart on the board right now, you can see it originally starts with the magma chambers. Now you do have a couple of them that do punch through to the surface, that punch through the volcanoes and stuff like that, but most of the magma is going to stay below the Earth's surface. Now, what happens is as it cools off, you see it turns into these intrusions. Those would be the grayish marks there. You see around it, it's kind of sandwiched in between the rock layers that look like they've got literally layers, like they're stripes. Those are going to be pre-existing rocks. Now, slowly over time, what can happen is the forces acting inside the Earth can actually sort of push these up. And so what you end up with, like you see on the bottom picture, is some of these intrusive structures get exposed to the surface. And that's how we would get like the granite or the diorite that actually we can see on the Earth's surface. All right, the first type of igneous intrusion we're going to talk about is what we call a sill. So what happens with a sill is you get intruding magma, which is a magma that, comes into a place that it's not supposed to be or wasn't before, and it enters the space between rock layers. And usually it does this by basically just melting the rock that it's working its way through. Remember, it's much, much hotter. And so it melts the rock that it's through, and it kind of forms this lava layer between a top layer and a bottom layer that are other types of rocks. Now, eventually that magma is going to cool off. It's going to form an intrusive rock, and what you're going to get is a layer of igneous rock, intrusive igneous rock, right, that is sandwiched between two other rock layers. And so what this tells you is that that sill had to have been created after the other two rock layers. So this is also an idea that we're going to talk about later in terms of dating things. But the igneous intrusion is always younger than the rocks that it intrudes. You can't go into something unless that something was there, right? You can't go into a house unless the house is already there. An igneous rock can intrude, go into an area if that area didn't already exist. So, like we see in the picture above, you can clearly see this layer of igneous rock that's between the two other layers. It's a much darker color than the rock layers that are above it and below it. Okay, it's going to have a different mineral composition. It's going to be a different type of rock. So this would be an example of what we call a sill. All right, guys, so the next type of igneous intrusion is what we call a dike. So a dike is very similar to a sill, but while a sill is a horizontal layer of igneous rock sandwiched between two other layers, dikes are usually either vertical or diagonal. They have more verticality to them than a sill. And what basically happens with this, guys, is they're going to cut across multiple layers. So they're not just going to melt a layer and fill in the gap. They're actually going to slice through it. So if you can imagine like a layer cake, okay, what this is basically doing is this is going to cut through the frosting and the layer of cake and the fruit and the other frosting. And so what that tells you is that what basically happened is you had magma that worked its way up, and as it worked its way up, it melted through all those other rock layers. Now, if it punches through the surface and becomes a volcano, you're going to get these quite often. Sometimes you could just have lava that's leaking out, or sometimes it never quite reaches the surface, but it still does manage to cut its way through it. So like you've been seeing in the picture that you look at, you can see the rocks in this picture that are kind of the brownish color, and then you've got this grayish, bluish igneous rock. That grayish, bluish igneous rock right in the middle is what we would call the dike. Okay, and so you can see how it cuts through it. Once again, this is another example of dating that we can use. This igneous intrusion, this dike, had to have formed after the other rock layers, the brownish red layers, formed. The only way you can cut through a cake is if there was a cake there for you to cut through. All right, guys, so the next group of igneous intrusions we're going to talk about are the massive plutons. Just like the name suggests, these guys are huge. They're going to take up a lot of space, and they're going to have a lot of mass and a lot of weight. Now, they're broken up basically based on their shape. The first type are what we call laccoliths. Now, laccoliths are mushroom-shaped igneous intrusions. Okay, they tend to form from felsic magmas, so they're going to have lots of silica in them. Okay, and once again, they tend to kind of have things like granite or pegmatite, rocks like that as their primary constituents. Now, a lot of times when we find mountains and stuff like that, we can see, for example, like you see in this picture, these would all have been originally a laccolith that got pushed up. The other example of a massive pluton is what we call a lapolith. Lapoliths kind of look like flipped over laccoliths. They're saucer shaped, so instead of being round on the top, they're round on the bottom. These guys typically are going to form from a mafic magma. Now remember, mafic magmas tend to have more iron and magnesium in it. And so what you end up getting is you get a lot of economically valuable minerals. You're going to get minerals that are really important to people for different trades, for different industries. That's what you're going to pull out of these things. So a lot of times when we find mines tend to be forming out of these types of structures. All right, guys. So the last group of igneous intrusions we're going to talk about are what we call batholiths. Batholiths are huge. They are the largest intrusions that we have. These guys are going to have surface areas of more than 100 square kilometers. Okay, they tend to form from magmas that have a lot of viscosity. What that means is they're very sticky. They're very thick magmas. Okay, most commonly they're going to tend to be things like diorite or granite. And being that these are the two major components of our continents, they tend to form the centers of most of our continents. Now, we find lots and lots of these guys all over the place. One of the places that we have, or one of the batholiths that we have best studied, is out on the west coast of California, right underneath the Sierra Nevada mountains. Okay, the Sierra Nevada mountains have a large mass of batholithic material just below the surface. That is where they came from. And so batholiths tend to spread out over huge areas. They tend to be very solid, and they tend to be the main component of most of the ground that we as humans tend to walk on. All right, so here we have an example of all of these different igneous intrusions along with some of the things that can form on the surface, and I just wanted to kind of go over that with you. So if we look right here, the big red mass right here, this is going to be magma, right? Magma below the surface, and then when it pumps its way out through a volcano, you get your lava. Okay, so this is all active molten rock. Now, as you can see, this all used to be rocks here, different layers of rocks. the bricks and the colors like that, the gray and all that stuff. What happened is this magma showed up and it melted all these things. Now, right now, it's a magma intrusion. It's not an igneous intrusion. Remember, it has to turn into a rock. But what's going to happen? Well, eventually, this is going to cool off. Some of it's going to get expelled, obviously, out the volcano. When that happens, you're going to get a lava flow. Eventually, that lava flow is going to harden, and it's going to harden into what kind of a rock? An extrusive rock. So this would not be an igneous intrusion. This would be an extrusive rock. Now, depending on what's in the magma, this could be examples of what? What are examples of extrusive rock? I'll give you guys a second. So you could have like a rhyolite. You could have an andesite, right? You could have a basalt, okay? Depending on what was in that magma. Was it mafic? Was it felsic? We don't know based on this picture. Now, eventually, right, you're going to cool off and you're going to get that right here. This is going to be your basaltic flows or your andesitic flows or something like that. Now, if we look down at this picture, we can see right here, we have a huge igneous intrusion. This used to be just like this. This cooled down and turned into a batholith. You see how big this guy is. Okay, but you can tell how before he used to flow out to the surface. And as he flowed out to the surface, he let lava out. That lava's hardened, and so has the stuff in the tubes. Now you can see this right here is the dike. Why? Because see how it vertically slices through everything? This is your sill. See how it horizontally slices through everything. Okay? And then over here, see you have a nice laccolith, right? Shaped like a mushroom. Then what would this little thing be here? This would be a dike. Okay, what would this little thing be here? This would be a sill. Okay, and then here we have a laccolith that's actually been pushed up. Okay, so some uplift process happened and it exposed it. Why? Because the ground around it eroded it, and so now we have what used to be an intrusive rock pushed up to the surface. It's still an intrusive rock because that's where it formed, but now it's been uplifted. So this is an example of kind of the stuff we were talking about at the beginning of the week with the rock cycle. All right, guys, so with that, we're done with igneous rocks. I hope it rocked for you. And make sure that you watch this video before you do the quiz, and I will see you guys later. All right, so everybody stay good, stay healthy, and I'll talk to you guys later. All right, bye-bye.